皆様、こんにちは。イーストゲートソフトウェア日本カントリーマネージャーの砂野翼です。本日はお昼の貴重なお時間に本セッション AI で開発は早くなったのになぜ手戻りは増えるのかにご参加いただき誠にありがとうございます。はじめに本日の進め方を3点だけご案内します。1点目、言語です。本セッションは弊社代表のHa Buiが英語でお話しします。ただし、全編にわたって画面下部に日本語字幕を表示しますので、どうぞ安心してご覧ください。2点目、質疑応答です。本編は約25分、その後の後半を Q&A にたっぷり当てています。ご質問はセッション中、いつでも Zoom の Q&A 機能にお寄せください。英語が基本ですが、日本語で書いていただければ、私が英訳してHaに連携します。率直な質問、気になる点など、どうぞお気軽にメッセージください。3点目、録画です。本日の模様は録画し、後日日本語字幕付きの録画を皆様にお送りします。途中でご退席が必要な方も、どうぞご安心ください。さて、本日のテーマです。AI によってコードを書く速度は確かに上がりました。しかし、多くの現場で手戻りはむしろ増え、ボトルネックは消えたのではなく、移動しただけ、そんな課題が挙げられております。タイピングの速さからビジネスが必要とするものと実際に作られるもののギャップ。本日はこのギャップを埋める私たちの答え、Agentic SDLC を包み隠さずご紹介します。特定のツールの宣伝ではなく、明日から皆様のチームでも検討できるエンジニアリングの手法の話です。それでは本日の登壇者をご紹介します。イーストゲートソフトウェア代表のHa Buiです。彼は昨今の開発現場で AI エージェント主体のデリバリーを納品できる品質できちんと回すための実践を自ら率いてきました。それでは、Haさん、よろしくお願いいたします。
Good afternoon. My name is Ha Bui. I am currently the CEO of Eastgate Software. So before I begin, one note, I will speak in English, and my team has prepared Japanese subtitles for this entire section. Please follow the subtitles at the bottom of the screen. I will try to speak slowly. Today, I will not demonstrate a product. I will describe an engineering method. Some of you are engineering leaders. Some of you are on the business side. And I have written this section for both, where the materials is technical. I will try to explain it in plain terms. We have three parts. First, the problem. Second, the method. And third, the evidence. So let's begin. So let's start with part one, the problem. So one number first. 78% of enterprise plan to build more custom software this year. Not buy, but build. 35% have already replaced a purchase tool with software they build themselves. And 60% of that software was built without oversight from the IT department. So this is the figure I ask you to hold. 60%. Software is being written inside your organization right now, outside your process. And this is the source coming from the survey in 2026 from Read2. And here's the pattern that we observe over again. We call it the maintenance gap. So weeks 1 to 4, a team builds a prototype with AI tools. The demonstration looks excellent. And then week 4 to 8, it is deployed. Maybe 5 to 20 users use it daily. It mostly works. And then when it comes to month 2 to 3, edge cases appear. there are no tests, there's no owner, there's no run book. And then from month 3 to 6, a decision arrives. Invest in real engineering or accept the risk. So the question is not whether your teams will build with AI. They already do. The question is whether the result can be maintained. Now here comes the real problems. AI made individual developers 10 times faster, but no company became 10 times more valuable. Why? Because the bottleneck was never typing speed. The bottleneck is the distance between what the business needs and what the developer understands. When requirements live in a chat history, 3 things are missing. There's no audit trail, there's no shared understanding, there's no way to verify intent. So the team iterates faster and rework more. As Martin Fowler's team put it, an agent is a model plus a harness, and the harness is everything that supports a model operation. So what do most teams do? They install Copilot on top of their existing process. Every developer forms private AI habits. The AI generates, nobody filters, and the AI agrees with everyone. The measure result is a 14 to 26% productivity gain. That is real. It is also additive. What we do is different. At Eastgate, we redesign the process around AI. Agents have defined roles. A harness separates signal from noise, and one agent is built specifically to say no. The difference between adding AI and redesigning around it is the difference between addition and multiplication. So before I describe our method, let me show you what happened without a harness. These are independent benchmarks and none of them are ours. So CodeRabbit reviewed 470 GitHub real pull requests. AI written code contains 1.7 times more issues than human written code, and 1.5 to 2 times more security vulnerabilities. GitClear, on the other hand, analyzed 211 million lines of production code. Since 2022, duplicated code blocks increased 8 times. So more code, more defects, more rework. So speed without structure is simply faster death. So what changed when structure exists? So now it comes to part 2 of the presentation, the method. I want to be clear about one thing. Eastgate did not invent what I'm about to describe. In February of this year, 2026, OpenAI published how their own engineers ship software with Codex agents. They gave the discipline a name called harness engineering. So the model provides capability, the harness provides structure, constraints, and verification. The central observation is this: when someone failed, the fix was almost never to try harder. The engineers ask one question instead: what capability is missing, and how do we make it enforceable? The team, with Martin Fowler's thought work, then gave us the vocabulary. There are 2 kinds of control. Guides steer the AI before it acts. Specification, domain context, architecture rules, and sensors verify after it acts, so including linters, test suites, review agents, human approval gates. So as an analogy, machine tool can cut any shape, but you build a jig to hold the part and a gauge to check it after the cut. So the jig prevents the wrong move, the gauge catches if it happens. So the model in this example is the machine, and the guide is the jig. So the sensor is the gauge. The machine did not improve. The fixture around it did. So for those of you on the business side, the harness is an internal control system. It is what an auditor would ask to see. The concept is public. What is scarce is running it on client's project. In regulated industries, with human approval at every gate, and that is exactly what Eastgate does. So this is what the harness produced. 3 engineers using Codex agents, approximately 1 million lines of production code in 5 months. Humans wrote none of it directly. They wrote the harness. Roughly 3.5 merge pull requests per engineer per day. And you can kind of compare that number to your own team deliverable output at the moment. So now we'll talk about our method, and we call it the Agentic SDLC, or Agentic Software Development Life Cycle. It has 5 layers. You can read it from the bottom, starting with layer 1, AI models and agents. And this is the raw capability. When you purchase an AI tool, you technically purchase the layer 1, so including Claude Code or Codex or Gemini. Layer 2 is a harness engineering layer, which is the control system. It has guides, sensors, hooks, rule. The next layer will be layer 3, specification-driven design. This is the contract. Behavior is specified before code is written. The AI builds from a specification, not from a conversation. And layer 4 is we pair it with test-driven development, the verification layer. So concrete examples defines done before implementation begins. And last but not least, layer 5, human in the loop. So it provides directions, judgment, decisions, AI propose and human approve. And every correction is fed back into the harness. So layer 1 is a purchasing decision. Layer 2 through 5 are the capability decision. All of these sit on our existing engineering practice, DevSecOps, continuous integration, automated testing, threat modeling. So we follow like our best practice from ISO 27001, and now it's very aligned with IEC 62443-4-1, which matters to our industrial and OT clients. So how do the agents actually operate? So you can think of them as an assembly line. The specification is the blueprint. It uses given when then scenarios, which is a BDD standard. It is the single source of truth for every role. Then there are 3 stations. Each agent owns specific files. They do not collide. Station 1, the backend engineer agent. It produces working backend code and unit test. Station 2, the front-end engineer agent. So interface and integration to the backend. Station 3, the tester agent. So it provides end-to-end tests and coverage against the specification. The final inspection, the code reviewer agent. It is a pass or fail gate before merge. So the harness is the standard manual that keeps the station from colliding. It is the production line with inspection stations. You already understand this model. I think it's worth to speak about the final inspector. So AI tools are differential by default. They agree with you. This is a defect, not a feature. So the most valuable agent in our system is the one that says no. It interrogates the code. Doesn't flatter the developers. It blocks any merge that does not comply with the specification. So to make that possible, some words are banned from our specification. Things like appropriate, reasonable, user-friendly, intuitive, efficient. Like how do you test user-friendly? You cannot. So every vague word must become a measurable condition. It is the add-in chord. Any station can stop the line. So this changed the shape of the team. A squad shrinks from 8 to 10 people down to 4 to 7 architects, operators, and agents. So who is the architects? Architects is the one who direct the system. They provide the why. And a business analyst or domain expert owns acceptance criteria. A solution architect owns architecture, security, and the harness rules. Second group is operators who run the system. They are mid-level engineers operating the harness. They validate AI output against the specification. They execute refactoring. They triage effects. The third group is the agents. The agents execute inside the harness, including back-end, front-end, tester, code reviewers, documentation, orchestrator. And there's an industry signal here. So according to Stanford's 2026 AI Index, junior developers' employment has declined approximately 20% since 2024. So the industry needs fewer people who write code. It needs more people who evaluate code. And our team structure is built around that shift. For the business side, this changed two things you own: your cost base and your hiring plan. So what changed when you adopt this? Every figure on this slide is from a third party, so either GitHub or Microsoft Research or McKinsey. I have deliberately included none of our own numbers here. So for the business, task completion is up to 55% faster. 56% of firms report reductions in engineering costs. For the engineering team, onboarding time is cut roughly in half, and documentation takes half the time. But I want you to look at the fourth item on the left, bounded technical debt. That is the one that matters. The pre-merge sensors block the 8 times duplication patterns I showed you earlier. Speed is temporary and bounded debt is durable. So the harness is not just a slide. It is an installable package, and we call it the Eastgate Engineering Kit. It is installed in every project as a development dependency. A new engineer inherits the standards on day one. There's 7 AI agents, 11 life cycle hooks, 13 coding rules, 24 knowledge packs, 60 role skills. And one thing more important than any of those numbers, it is portable. So specifications, rules, and agent definitions are plain files in your Git repository. There's no proprietary editors, there's no license runtime, nothing is locked. Every file lives in your repository. The client owns everything. So I have already go through the issues and then the method. Now going to part 3, which is the evidence. And in here I will present 2 examples. Both deliver this way. So the first one is the GAP platform. The project is a workstation for motorway operators under a German government initiative. The project has 7 engineers in a period of 10 months. The stack is quite common for enterprise, which is Java, Spring Boot, React on a private cloud. And the system collects daily motorway sensors data. It visualizes traffic conditions and it supports traffic state prediction. So the outcome, traffic event detection accuracy between 92 and 95%, data processing latency reduced by 40%, incident response time improved by 25 to 35%. And now come the delivery numbers. 40% of merge code originated from AI. End-to-end test coverage grew 1.5 times through the tester agents. Feature lead time fell 30%. And one sentence I want you to note: no AI ships unreviewed. Every data model, every alert threshold, every deployment signed off by a senior engineer. Because this is a government project, there's no other acceptable way. The second example is a casting plant in the United States, factory management. So the project has 3 engineers, 10 months, and the client currently track production carts from casting to shipping using disconnected tools, no real-time visibility, retroactive scrap tracking. Everything is paper-based quality control. So we deliver one platform, a stage pipeline dashboard, a drag and drop cart movement, enforced quality checklist, scrap tracking with automated alerts, and sensor data integration. So 6 systems become one. Manual tracking effort fell 70 to 80%. Cart visibility is now 100% across all stages. So please note on the team size, 3 engineers and 90% of merge code originated from AI. Test coverage grew 5 times and feature lead time fell 55%. So under the same human approval gates as the German government project. So how would you evaluate this? There's 2 engagement. Option A, so your team already using AI coding tools, so Cursor, Copilot, Claude Code. So we install the harness on one project for 2 weeks, specification templates, reviewer agents, life cycle hooks, quality gates, fixed scope, fixed costs. You receive a before and after report. Option B, you have an AI build application in production. It mostly works. There's no owner, no test, and unknown risk. We can conduct a 1 to 2 weeks audit, and then option B will produce 2 artifacts, a risk register, and a 90 days remediation roadmap, nothing else. We do not require production access, which isn't the source code for this. But I'm not asking you to choose today. What I would like is maybe 30 minutes with each of you. Want to understand your current situation. I will tell you honestly which of these 2 would fit, or maybe there's a 3rd or the 4th option. But if there's neither option fits, I would say so. The full white paper is on our website. My team will share the contact details. And thank you very much for your time today. Our team will really appreciate it, and have a nice day ahead.
プレゼンテーションはいかがだったでしょうか。それでは Q&A セッションに入る前に、せっかくの機会ですので、弊社の社員がどのように AI を使って開発を行っているか、デモンストレーションの動画も合わせてご覧ください。
A 4-phase walkthrough showing how the EGS engineering kit takes a feature from client brief to production-ready code, using Claude agents at each stage. This is a demo of the EGS engineering kit from a BA's perspective. We start with the brief and mockups received from the client, typically delivered after the initial discovery discussion. First, install the EGS engineering kit and launch Claude from the terminal. Once Claude has initialized and loaded the required skills, we run the first step in the BA flow, BA brief, which analyzes the client's requirements. Before moving on, we answer a few clarifying questions, or loop back to the client for confirmation, to make sure the requirements are unambiguous. With the high-level requirements locked in, we trigger the BA story skill. It analyzes the feature, breaks it into user stories, and produces clear acceptance criteria, edge cases, and scope boundaries for each. Next, we run BA review to validate the story against the original requirements and our quality gate, guarding against scope creep. Claude scores the story, surfaces any issues, and prompts us to resolve them before continuing. The quality gate blocks forward progress whenever a critical issue would affect functionality or break alignment with the brief. Once critical issues are addressed, we rerun the review to validate the updated story. When every criterion passes, we move on to the test plan and handoff to the technical team. BA handoff produces implementation brief for developers, technical constraints and decisions, APIs, database, integrations, test contracts derived from the test plan. With the BA test plan and handoff complete, the tech lead agent takes over to produce a phased implementation plan with file ownership and a test strategy. What the tech lead does: 1. Reads the BA handoff and test plan. 2. Researches the codebase for existing patterns. 3. Creates an OpenSpec change, OpenSpec new change shop floor dashboard. 4. Produces a phased plan in plans, plan.md, overview with phase status table. Phase-01-backend-api.md, REST endpoints for machines, work orders, KPIs, WebSocket server for real-time updates. Phase-02-frontend-dashboard.md, dashboard layout, machine status grid, KPI cards, filter controls, WebSocket client. File ownership per phase, no overlaps. Test strategy, unit plus integration plus E2E. Risk assessment. With the implementation plan approved, we launch parallel agents to build the feature using TDD. For this demo we'll run only the front-end and QA agents to keep things tight. 3 agents run simultaneously: back-end engineer, front-end engineer, tester. The test agent analyzes every component and generates test cases from the BA test plan, closing the loop between requirements and verification. Once the agents finish, we review their output and request any changes needed. The agents apply the updates and the implement and test cycle repeats until the feature is ready. Finally, with Claude Design, we refine the UI and hand the polished design directly to Claude Code for implementation, closing the loop from brief to pixel-perfect feature.
はい、ありがとうございます。それでは Q&A セッションの方に入りたいと思います。いくつか質問をすでにいただいておりますので、質問内容、英語と日本語分かれておりますので、それぞれ私の方で翻訳しながら進めていきたいと思います。So I'll translate to English, so please answer
Okay.
one by one. Okay. では、一つ目のクエスチョンです。質問ですね。内容としては、Agentic SDLC は既存のスクラム開発と併用できるかどうか、もしくは、開発プロセス全体を置き換える前提かどうかという質問ですね。So, can Agentic SDLC be used alongside our existing Scrum process, or does it assume replacing the entire development process?
Thank you, Subhasa. So I think the purpose of Agentic SDLC right now is not to replace the entire development process, but is to supplement to that the Scrum process overall. And from our experience in the last few months, I think it's better to work in a hybrid mode. So focusing using AI to focusing more, especially during the planning and architecture phase, and then later on kind of combine that process with the traditional Scrum process as well.
Thank you. そうですね。回答といたしましては、既存の、開発プロセスを全て置き換えるというのが目的ではなくてですね、この既存のスクラムプロセスに補助的に加えていって対応するハイブリッドモデルというものを想定しております。ですので、まず要件定義やアーキテクチャのからの計画をまず重点に置いて、どのように今の既存の開発モデルからこの開発手法を加えていくか、そういったところが大事になるというふうに回答いただいています。それでは次に行きたいと思います。Okay, next question. 日本語ですね。導入する場合、最初はどの工程から始めるのがおすすめですか？ So, when you introduce this new method, what is the first process that is recommended?
Yeah, so I think it depends on the type of project that we apply this framework to. So if that is a brand new project, so it's like what we call is a greenfield project, then we will start with focusing a lot on the requirements and architecture to make sure that like we create the foundation and so structure around AI. So that's for greenfield project. For brownfield projects, which mean like there's some existing solution that the company already has, then we will start with also not jump right directly to the requirements yet, but we have a process to do the discovery, meaning we map out and what we call as a reverse engineer all the relationship within the code base or the existing requirements. And then we can also kind of reverse engineer the architecture as well. So the discovery phase is also important. And then we kind of rebuild the structure for the existing code base. And then that will create the structure for AI to work on later.
はい。回答といたしましては、2パターンございまして、まず、完全に新しいプロジェクトを、からの導入をする際には、グリーンフィールドという言い方をしてたんですけれども、そこに必要な、要求内容と、条件ですね。こちらをしっかり土台として、理解する、把握するというところから始めて、導入するというパターンですね。でもう一つが、ブラウンフィールドですね。すでに既存にあるプロジェクトを、利用する場合は、リバースエンジニアリングという形で、すでに作られているコードをしっかり理解した上で、どのように構築していくかという 進め方の2パターンになるというところでございます。はい。ありがとうございます。では、次の質問ですね。御社ではどの AI モデル、ツールを使っていますか？特定のツールに依存していますか？というですね。So, which AI models and tools does Eastgate use, and is also the framework dependent on any specific tool?
To answer this question, so we have two phases for this framework. We are at the we completed the phase one. So phase one would be we build the framework using anthropic models. So right now, especially on the architect group, which doing all the requirements and architectures, we're using Opus as the model for those activities. And then we use Sonnet for implementation in QA and testing activities. And that is the phase one of our framework. We are in the middle of phase two to make it more generic. So be able to use this framework also with Codex, so GPT, and then also with Gemini as well. So in order to do this, about 90% of what we build with Anthropic is reusable. We just need to tweak the other 10% to make it work with the other AI providers.
回答といたしましては、まず、フェーズが2つに今、弊社の場合分かれておりまして、1つ目のフェーズ1に関して言うと、アンソロピック社のモデルを推奨しているモデルを利用して、クロードのモデルですね、を使っておりますと。プランニングですとか、アーキテクチャの設計の部分では、オーパスを使って、実装、開発のところ、QA、テストのところに関しては、ソーネットを、利用しているというところです。で今、次のフェーズとして会社が取り組んでいるのは、クロードのモデル自体は 90% 以上使っているんですけれども、他の 10% のところで、コーデックス、チャット GPT ですとか、ジェミニを使って、補完的に、利用しているというところでございます。はい、ありがとうございます。Okay, another question. Okay. テスト担当エージェントとレビュー担当エージェント、具体的にはどのような観点で成果物をそれぞれお互いに検証していますかという質問です。Another question is, about the testing agent, between testing agent and review agent, what specific criteria do they use to verify deliverables?
I think it all based because during the requirements and architecture phase, we spend a lot of time collecting the requirements from the business and also creating SRS, which is a software requirements specification, and then define the acceptance criteria for different features. We build test cases, so happy case, sad case, and edge cases. The testing agent and the review agent, we all kind of validate against those information.
So each agent has a different criteria.
Yeah, so features we will define acceptance criteria and all test case related, and then the agent later on we just review on those specification.
そうですね。それぞれのテスト担当のエージェントとレビュー担当エージェントで必要な確認する基準が違いまして、その基準に基づいて、 成り立ったものが、その後、さらに、チェックされるという仕組みになっているんですけれども、SRS ですね、ソフトウェア要求使用書で定義された受け入れ基準が、テスト担当エージェントのところで、それが実際に、レビュー担当エージェントのところでテストケースが正しく、動いているかどうか、エラーが出ていないかというものが、確認される、そういった仕組みとなっております。OK。次の質問です。Another question。人間の承認ステップですね。では、レビュアーは何を見るべきですか？全コードを読むのは現実的ではない気がします。Yeah, it's checking too many codes by human isn't realistic. So, which criteria or what humans should check?
Yeah, so this is a good question because I think AI can generate a lot of code in a short period of time now. So what we during the architecture phase, the output that we check would be definitely the SRS, the specification of the software and the architecture as well. So like a lot of different XML diagrams that we need to verify there. And then during the implementation phase, right, we will write a lot of tests, automation tests, to validate against the acceptance criteria, and that is how we actually doing the sort of feedback based on the output of AI. We don't really spend much time to review the code as it used to be in the past, but we validate the output based on the automation tests.
そうですね。アウトプット、AI の場合ですと、コードを大量に短時間で書くので、それをすべて人間の目で確認するのは、現実的ではないというところで、何を確認するかと言いますと、SRS ですね。ソフトウェア要求使用書が、基準をクリアしているかどうかというところと、アーキテクチャの設計の部分ですね。あと、自動で対応されるそのテストの数をたくさん基準を設計することで、そのテストケースの結果を人間の目で確認する。そこにレビュアーとしての重点を置くというところで回答いただいています。Thank you. Next question. So, can this be applied to a large legacy code base? Sorry, I need to translate Japanese too. レガシーコードベースが大きい場合でも、このアプローチ、このAgentic SDLC は適用できますかという質問です。
Okay. Yeah. So I think using AI and Agentic SDLC in large code base is actually a very good use case because in the large code base, right, I think there's many knowledge that has been transferred over the year, and maybe the developers who work on those projects maybe already left the company, or they didn't have time to write a lot of documentations. So using AI SDLC, especially the discovery phase that I mentioned, they will really map out all the existing logic living in the code base into some of the well-documented documentation, and using that as the baseline to move forward. So it's definitely really useful case for large code base or legacy. Yeah.
回答といたしましては、そうですね、レガシーの、ちょっと古いタイプのコードベースでも、きちんと有効であるというふうに考えていますというところですね。特に、 引き継ぎの書類とか、すでに対応していたエンジニアが退職されていて、残っていない資料などがあったとしても、残っている資料を基準にして、AI を使って対応していくということは十分可能であると、いう回答がございました。ありがとうございます。OK。次の質問ですね。エージェントの実行コストとレビュー工数を含めると、トータルで本当にコスト削減になっていますか？そうですね。Okay. The question is, so, is the including agent running costs and review effort, is this really a net cost reduction overall?
So we only was able to test on maybe about five projects in the past a few months, and what we see as an average, we see the development or implementation effort from the developers sort of reduced to be 30 to 40%. But it's not necessary like we reduce that 30 to 40%, right? I think we spend about 20% of that extra time on some of the activities that we never be able to spend before. So on the automation tests and like unit tests and like maybe stress testing to enhance the quality. So as the net cost reduction, I would say at the moment is from 10 to 20% overall on like some of the large scale project.
But we still spend more like spend the time and the effort for the quality part.
On the quality part, yeah.
回答といたしましては、開発工数という点だけで、見た場合ですね、この数ヶ月で、弊社イーストゲートソフトウェアが、このアジェンティック SDLC を導入してから、5つのプロジェクトを対応して、だいたい 30% から 40% の開発工数の削減というものが平均として見られたと。ただ、実際には、その、全部こう浮かすっていうわけではなくて、品質向上のための自動テストですとか、単体テストをより、その浮いた時間で使うというところで、全体的なそのコストというところで見たときには、10% から 20% の削減です。Okay. Thank you. Okay, there's another question. レビューエージェントの精度をプレシジョン、リコールで測定していますか？人間レビューと比較したディフェクトエスケープレートの実データがあれば伺いたいです。Okay, new question. The accuracy of the review agent measuring by precision or recall by if we have the actual data of defect escape rate by human review comparison, it is helpful.
Very good question. So we didn't do this comparison on all the 4 to 5 projects that we tested, but we did on one of the sort of like the last project, the 5th project that we did, and we do it sort of like side by side. So we testing. Our test is more of like an A and B testing. So we put 3 features for the human to test, and then 3 features using AI. And the defect escape rate for the first group is somewhere around like 18 to 20%. And then with the AI right now on the second group of those 3 features is from, I think, 8 to 9% at the moment. So there's definitely a certain improvement on the defect escape rate. But that being said, I think there's maybe a few more techniques to combine between human and the testing agents to reduce that defect escape rate even more.
はい。今までの弊社で対応している5つのプロジェクトのうち、最後の5つ目のプロジェクトで、AB テストという形で実際の人間のレビューの場合と、AI を使った場合の、ディフェクトエスケープレートを測定してみております。で、実際に人間のレビューでやった場合ですと、18% から 20% ぐらいのエラーですね。レートが出てまして、AI を使った場合ですと、8から 9% の結果が出ていたということです。ただ、実際には、AI のレビューと人間のレビューを組み合わせて、より精度の高いものができるというふうに考えております。です。はい。回答になりましたでしょうか。ます。Project is not suited for. Another question. そうですね。この、フレームワークが機能しなかったケース、もしくは向いていないプロジェクトの特徴などはありますか？Can you share a case where this framework didn't fully work, or what kind of project is not suitable for this method?
So at the moment we work on we have some experience working on greenfield projects, and that is a very good fit. So MVP and greenfield project is very good fit. For some of the large code base, right, is also quite fit. But when we say large, is only a project with 20 to 25 like mini projects within. But we haven't worked on any other we don't have any experience working on the like more projects rather than 25 to 30, right? But what we see that it might be an issues for this framework is when we work on a large code base. Let's say the whole ecosystem is like 40, but then the AI framework that we have only access to maybe half of that number of projects. So AI framework won't have the context of the whole ecosystem, and it doesn't have the whole context of the source code or the documentations, and that will also maybe reduce its capability to work on like 100%.
まず、この手法が、有効なケースでお伝えすると、グリーンフィールドですとか MVP の小規模なサイズですね。新しいものですが、小規模なサイズというものは有効であると考えていますと。で、その他、あと、大規模な、レガシーコードに関しても、20から25ぐらいまでの、プロジェクトが連なっているものであれば、対応は問題ないというふうに考えていますと。ただ、それ以上の大きいところっていうのは、弊社としてまだ対応してないので、何とも言えないんですが、懸念しているところとしては、AI がすべてのソースコードを読み込めないサイズですとか、アクセスできないプロジェクト。なので、大きな、レガシーコードシステムの、40以上プロジェクトがあったり、半分以上ソースコードにアクセスできない状態で、コンテキストって言い方してましたけど、前後関係の情報が取れない状態で開発進めると、あまり向いてないんじゃないかというところで回答いただいています。はい。Okay. We answer all the questions so far. 今のところいただいている質問にはすべて回答しているかと思います。そうですね。今のところ特になさそうですので、大丈夫ですかね。はい。今回、 弊社のこの数ヶ月の中で、Go プロジェクト対応して、これからもどんどん進化していくんですけれども、実際の会社、皆様の会社でも取り組んでみたいなというものがもしございましたら、いつでもお気軽にご相談などいただければと思います。Do you have any comment in the last before closing meeting?
No, I think that's all good, and thanks everyone that attend the webinar today, and I appreciate you spending the valuable time with us. And then, if any questions, then we will reach out through emails and discuss from there.
はい。最後にこちら翻訳して、終了したいと思います。はからですね、本日はお時間、貴重なお昼のお時間頂戴いたしましてありがとうございます。で、また、こちらに関するご相談とかご質問とかありましたら、メールですとか、お打ち合わせなどで、はい、ぜひ、対応させていただければと思いますので、引き続きよろしくお願いいたしますというところです。では、本日はお時間、ちょっと早いんですけれども、頂戴しましてありがとうございました。また、こういった機会設ければと思いますので、その際はぜひよろしくお願いいたします。ありがとうございます。それでは、失礼いたします。